Okay, this is another skiing technique. It's called maximizing the distribution of force application. All right, and the primary purpose of maximizing the distribution of force application is to avoid concentrations of force application, either in the form of pressure, which is force distributed over area, or impulse, which is force distributed over time, which exceeds shear force, break snow bonds, throw snow, and thus bleed energy, right? Making your ski slow. All right, now a secondary advantage of maximizing distribution of force application is to avoid intense anaerobic muscle exertion that can build lactic acid and fatigue muscles. It's also inefficient in utilization of ATP. All right. Um, all right. Okay. Now, so I'm talking about breaking ice bonds. These are the bonds between water molecules to form ice. Here's a water molecule HOH, H2O. Another HOH. Right? You see how they're bonded together when they're frozen. Now, shear force is a force that scrapes along the surface. In this case of ice or snow, and it can break these bonds, right? Which requires energy. All right. So the goal here is to maximize distribution of force application. All right, and these are each ways of doing this. All right, and this is the beneficial effects. So we'll go through these one at a time. One thing you want to do is maximize distribution of force application along the entire length of the ski. Right? Don't ski on your tails, or uh, if you concentrate force over a small area, you increase the likelihood of exceeding shear force, breaking ice bonds, throwing snow, skidding, and thus bleeding energy. So generally, you want to uh, spread out the pressure along the entire ski. Now, if you concentrate force application too far forward or aft, you will, one, fail to utilize the full edge grip of the ski. Two, fail to utilize the full flex of the ski to arc it into a carved turn. All right, remember, I showed you a picture of a ski's flexed. You lay it on its side. Well, it follows that arc. If you don't engage the tips of the skis, you will not initiate turns quickly or cleanly. And two, you will increase the likelihood you'll wash out your tails during turns, right? Now, one exception to this rule is in slalom or in giant slalom, in which you can utilize the method called energy storage, roll, and release. All right. All right. So now the next thing is you want to maximize distribution of force application evenly across both skis, right? So here you want to apply force evenly throughout the ski. Here you want to apply force evenly across both skis, relatively evenly. I mean, you generally want to weight your outside ski more. Uh, However, when you have counter rotation, all right, this draws the skis closer together. Counter rotation with slip and slide, that draws the skis closer together, allowing force to be distributed more evenly. Now, in GS, Super G, and downhill, a combination of hip angulation with a crunch, right? You bow at the waist, and this will lift the upper body center of mass to create the lever arm that torques weight onto the outside ski. However, the counter rotation with counter rotation, you can more evenly weight both skis. That's the advantage. All right. Maximize distribution of force application along the entire length of the course. Now, this is especially important for Super G and downhill, both of which have high turn to transition ratios. All right. In these, the transition is relatively fast compared to the turns. You're in turns for a long time. All right. So the difference between slalom and GS is, in both of those, the turns are pretty quick, about as fast as that transition. All right, so the conventional wisdom used to be to run the skis flat as long as possible between turns. All right. The idea was the shortest distance between 2 points is a straight line. All right. I mean, this is real simple thinking. Like, okay. Um, Also, running the skis flat has the least resistance. All right. And I say, do not do this. Don't follow conventional wisdom. Don't follow the simple, thinking inside the box. Um, Instead, do the opposite. Constantly be in a turn to maximize even distribution of light force. Right now, the friction or resistance of that light force, constant light force, as long as you're not, as long as you're carving and you're not breaking ice bonds, throwing snow, right? It's going to be very little more, than running them flat, right? All right. This requires quick and clean transitions. All right. In fact, I'll show you. Show you some videos now. All right. So this is the latest Super G race, women's. All right. This person here got third place, I believe. Her name is Suter. So what I want you to keep in mind is, notice how they're doing. They're constantly in a turn, and they try to get quick transition. They switch their slip and slide from one side to the other. All right, so that's slip and slide to the right turn. All right, and switch it. See how fast you switch it? So they're switching it there. All right, and switching it back in a second here, right there. So that's the transition. Notice how they're almost back into the turn right away. You're not running it straight. Now the idea is, if you're constantly in a turn, you're spreading out that force application, right? And it's a light application continuously. If you run it straight and do a hard turn when you get to the gate, you're going to be skidding a lot. You're going to be breaking all sorts of ice bonds, throwing snow, and you're going to bleed energy. I don't know. Your carotid artery has been cut. You're just gushing energy. And then you're slow, and it takes time to build it up again. Switch. See that switch? All right. Right. Okay, she's doing a switch there. Transition. Switch to the slip and slide. All right. In a turn, switches it. Slip and slide this way. In a turn. See how she's got her body rotated out a little bit? You can do that in a downhill tuck. You see the transitions there? All right, she's in a tuck. All you got to do is pull back an elbow and roll your body to the outside. See how she's facing the outside a little bit? Slip and slide to the left. Transition, slip and slide to the right. All right, transition again. Watch it push the left ski forward. All right. Rotate it out to the right outside here. Right. See the switch? You try to make that quick. Throw the skis over, lift the knees over the hump. All right. Constantly in a turn. That's today's technique. I taught that. I said, don't do the conventional thinking. Now, this person, she won the race, Austrian girl, I think. So, you see that transition there? See it in slow motion. Slip and slide, right to the left. Switches it, quick. Slip and slide to the right. Body rotated out to the outside. She's got bull horns, but she's got good slip and slide. Switches it. Rotate it out to the outside. Switches it. Slip inside left. Watch her switch it. Switches it. All right, slip inside right. Angle it to the outside. See how fast she switched it? Slip inside right to slip inside left. Angled outside. Switches it there. She was very smooth. I think that's why she won. She beat this other girl by 1/100th of a second. Switches it there. Switches it there. See that? It's almost like a scissors. Slip inside left. Push that left ski forward. Slide the other right ski back. See how she pulled out her elbow back there? Slip inside left. Okay. This girl got second by 1/100th of a second. Rotated outside. Switches it. Slip inside left. Oh, that's the same thing. Why do I have that twice? Slip inside left. Got on her tails a little bit. Slip inside right. Switches it. See that slip inside? Skis fairly close together. Body angled out a little bit. Body rotated the other way. Skis rotated in this way. Slip inside left. Switches it. Pulls that outside arm back. Oh, check that out. She leaned in a little bit. You know, it's kind of dangerous. She shouldn't drop that hand like this. She got nervous, dropped the hand. Well, that's the wrong thing you want to do. You want to keep that inside shoulder lifted so that the shoulders are horizontal with the horizon. All right. This shoulder's a little high. All right. This is drop low. All right. See how she's leaning in? Well, she could do roll down and slide out very easily. She's got a little bit of angulation that's helping her. Yeah, see how she slid out? She washed out low a little bit. See that? See that again. So she's going to wash out. She's sliding out. See, she's sliding down. So they're being very subtle with the upper body, but they're driving slip and slide. Look at that. You can drive slip and slide without a lot of upper body rotation if you actually rotate your lower body so that you press that butt cheek towards the snow. All right. So that's slip and slide with counter rotation.
This is another support video for the method of getting counter rotation in your shoulders.
All right. So yeah, that's how you do quick and clean transitions. They switch the slip and slide rapidly. I don't know exact numbers here, but I'm talking about coefficients of friction. So I don't know the exact numbers. It's probably going to vary with conditions and with material, right? But intelligent logic tells me that the coefficient for sliding friction is the coefficient for skidding friction is much greater than the coefficient for sliding friction. Right? It is true that there is only sliding friction when running on skis flat, but the same is pretty much true of a moderate turn that is carved with minimal snow being thrown. Right? You're just running sliding friction. Now, granted, that sliding friction is going to be nominally more than running it flat, right? But the trade-off is if you run it flat to try to run, as straight as possible gate to gate, when you get to the next gate, you got to throw down a hard turn. That's going to just bleed all sorts of energy. It's going to break all sorts of ice bond. It's going to have all sorts of skidding friction. It's going to throw all sorts of snow, and you're going to be slow after that. All right, you might as well throw in a hockey check stop, and then it's going to take a good amount of time to build up speed again. Right? Overall, you're slow. Okay. So the big difference is running straight and flat requires hard turns that cause great amounts of both ice bond breaking, snow throwing, and skidding friction. All right. Okay, next is utilize the full rut in slalom and GS. Engage the tips of the skis to start storing energy early at the start of the rut. This will maximize distribution of force application. All right. So one thing is you got to make sure that you initiate turns with the tips of the skis. All right. Don't sit too far back. All right. Don't have your chest pulled back or raised high. All right. You're gonna engage. At the latter part of the shovel. All right. And you're gonna hit that rut late. And if you hit it late, the rut's curved. All right. So because the rut's curved, if you hit it too late, you will hit it too perpendicular. So you're coming like this, right? Coming in. Here's the rut, right? If you hit it late, you're hitting when it's already turned a good bit. So you're hitting it more perpendicular. And if you hit it like that, you're going to impact it with high impulse, risking shear force, ice bond breaking, skidding friction, and you apply force instead of storing energy within the ski. You're not going to store energy within the ski if you hit it like that. All right, minimize upper body flow time. All right, this is another way of maximizing distribution of force. All right, if you have too much flow time, you got to wait until your body comes down to apply force, and then you got to throw in a lot of force in a short amount of time. So you're concentrating force application, right? Don't let your upper body float high in the air. Keep it always low, and then shoot out your legs as fast as possible after your legs have crossed over the hump. You cannot apply force on the snow until your upper body lowers. Therefore, keep the upper body mass low all the time. To do this, pull up your legs as they transition over the hump. When they come up beneath you, pull them up, right? So it doesn't shove up your upper body. Then, as they pass to the other side, shoot them up to rapidly re-engage force application. Lower your upper body as you approach a fall away so that you can shoot down your legs to rapidly re-engage force application. So you fall off a drop away, right? Go low. Have your upper body low before you go over. Then, as you go over, you can shoot down your legs. So your lower body's compressed, and then you shoot down your legs. Keep the upper body soft to absorb all bumps, to smooth force application. By skiing with a loose body, all bumps will be absorbed, avoiding little spikes in force application throughout the course. I used to think this: ski like water, especially in Super G and downhill. Keep your body fluid. Use counter rotation to prevent rebound energy release from skis, tossing you into the air. Right. So if you have counter rotation. If you don't have counter rotation, when you get the rebound energy out of skis, it's going to throw you in the air or flip you on your back. All right. But with counter rotation, it's going to throw your legs laterally, facilitating the transition to the next turn, making it quicker, so you can apply force more rapidly. Right? Okay, now, so these are ways you can maximize distribution of force application, and the effect is only sliding friction, or at least you only have sliding friction, or at least less skidding friction, right? So it's gonna, by maximizing spreading it out, you can have light force, right, spread throughout instead of like concentrated force, at a hard turn, and you have less skidding friction, you have less ice bond breaking, so minimize shear force and subsequent breaking of bonds. You have maximum retention of kinetic energy. You have clean, quiet turns with minimal disturbance of snow, less muscle fatigue, and also I forgot up here, your skis are gonna carve cleanly because you're evenly distributing weight across both skis. Okay, that's it for that lesson.